Right now, a spacecraft older than many of the people reading this is operating with an astonishingly small amount of power, billions of kilometers from Earth. A radio message takes almost an entire day to reach it, and yet this nearly 50-year-old machine is still collecting information from a region of space no human being has ever physically visited. This is the story of Voyager 1, and in 2026, its journey has become far more extraordinary than the engineers who built it in the 1970s could ever have imagined. When Voyager 1 launched in September 1977, its mission was never supposed to last this long. Along with its twin, Voyager 2, the spacecraft was designed primarily to visit Jupiter and Saturn, photograph their moons and rings, gather scientific measurements, and then eventually fade into history. The original mission was expected to last only a few years. Instead, nearly half a century later, Voyager 1 is still communicating with Earth. Its extraordinary journey was made possible by a rare arrangement of the outer planets. Jupiter, Saturn, Uranus, and Neptune were positioned in a configuration that allowed a spacecraft to use the gravity of one planet to accelerate toward the next. Engineers called the concept the Grand Tour. Voyager 2 launched first, but Voyager 1 followed only a couple of weeks later on a faster trajectory. It quickly overtook its twin and began a journey that would eventually carry it farther from Earth than any other human-made object. Only a few weeks after launch, Voyager 1 performed an observation that would become iconic. It turned its camera toward home and captured Earth and the Moon together in the same frame. Our planet appeared as a tiny point suspended against the enormous darkness of space. It was an early reminder that even before reaching the outer planets, Voyager was already changing the way humanity viewed its own world. Then came Jupiter. As Voyager 1 approached the giant planet in 1979, it revealed a world dramatically more dynamic than anything scientists had imagined. Jupiter was surrounded by powerful radiation belts, enormous storms, complex magnetic activity, and a collection of moons that looked almost like a miniature planetary system. The spacecraft discovered faint rings around Jupiter and helped identify previously unknown moons. But some of the most important discoveries came from the moons themselves. Io was perhaps the biggest surprise. Voyager 1 detected active volcanoes erupting across its surface, providing the first direct evidence of active volcanism beyond Earth. Instead of being a frozen, inactive world, Io was violently alive, driven by enormous tidal forces generated by Jupiter and its neighboring moons. Then there was Europa. Its surface was covered with fractures and strange patterns that suggested something extraordinary could exist beneath the ice. Voyager's observations helped strengthen the possibility that Europa could contain a global ocean of liquid water hidden beneath its frozen exterior. That idea would eventually become one of the most important concepts in modern planetary science. Perhaps life does not need to exist on the surface of a warm planet. It might survive inside an ocean buried beneath kilometers of ice. After Jupiter, Voyager 1 continued toward Saturn. The spacecraft arrived in 1980 and once again transformed our understanding of the solar system. Saturn's famous rings, which appeared from Earth as a few simple bands, were revealed to contain an astonishing number of individual structures, gaps, waves, and narrow ringlets. Voyager also discovered additional moons and gathered unprecedented information about Saturn's atmosphere and magnetic environment. But the most consequential encounter involved Titan. Titan's atmosphere was so thick that Voyager 1 could not directly see its surface using ordinary visible light cameras. Yet measurements of the atmosphere revealed a world with an extraordinary chemistry. Titan was cold enough for methane to exist in forms analogous to the way water behaves on Earth. That raised the possibility of methane clouds, rainfall, rivers, and lakes existing on a distant moon. The encounter fundamentally expanded the scientific discussion about what environments might be capable of supporting complex chemistry. But studying Titan came with a permanent consequence. Voyager 1 was directed close enough to Saturn's largest moon that Saturn's gravity dramatically changed its trajectory. Instead of continuing toward another planet, Voyager 1 was sent onto a path that carried it out of the plane of the solar system. Its planetary exploration career was effectively over. Something else had begun. Voyager 1 was becoming an interstellar spacecraft. There was another part of the mission that had nothing to do with planetary science. Attached to the spacecraft was a golden record. It was created as a kind of message in a bottle for the universe. The record contains greetings in dozens of human languages, natural sounds from Earth, photographs encoded as data, information about humanity and our planet, and a carefully selected collection of music. It was an extraordinarily optimistic idea for a spacecraft that was originally expected to operate for only a few years. The people behind the project knew the probability of another civilization ever finding the record was incredibly small. But the message represented something larger than its practical purpose. Humanity was sending a small representation of itself into the unknown. And nearly 5 decades later, that record is still traveling with Voyager 1. After Saturn, the spacecraft continued outward. For years, there was no dramatic planetary encounter. No spectacular images. No new world appearing in front of its cameras. Just distance. Voyager 1 continued moving farther and farther from the Sun until it reached a region where no human-made object had ever traveled before. Then came one of the most important moments in the history of space exploration. On August 25, 2012, Voyager 1's instruments detected a dramatic change in its environment. The population of charged particles originating from the Sun dropped sharply, while energetic particles arriving from outside the solar system increased. Scientists interpreted these measurements as evidence that Voyager had crossed the heliopause, the boundary where the solar wind gives way to the interstellar environment. For the first time, a human-made spacecraft had entered interstellar space. But the boundary wasn't exactly what scientists had expected. The heliosphere was not simply a soft, gradual transition where the influence of the Sun slowly disappeared. Instead, Voyager encountered a complex region where solar material and the surrounding interstellar environment interact. The discovery forced scientists to rethink the structure of the enormous bubble created by our Sun. And then Voyager began detecting something even stranger. Interstellar space wasn't silent. The plasma wave instrument detected faint oscillations in the surrounding plasma, allowing scientists to study the density of material between the stars. To human ears, these measurements could be converted into an eerie, almost ghostly sound. It wasn't an alien transmission. It wasn't a message. It was the natural behavior of plasma in interstellar space. But the discovery was still remarkable because it allowed scientists to measure an environment that had previously been almost completely inaccessible. Voyager's measurements also showed that the interstellar magnetic environment was more complicated than many earlier models had predicted. The spacecraft was revealing that the space between stars is not simply an empty vacuum. It contains particles, magnetic fields, waves, pressure, and structure. The solar system exists inside a much larger galactic environment, and Voyager was finally giving humanity a direct measurement of that environment. Voyager 2 eventually crossed the heliopause as well, in 2018. Because it entered interstellar space at a different location, scientists were able to compare its observations with those from Voyager 1. The results showed that the heliosphere is not a perfectly symmetrical bubble surrounding the Sun. Its shape is influenced by the surrounding interstellar environment, the motion of the solar system through the galaxy, and the interaction between solar and galactic plasma. 2 spacecraft, launched in the same decade, had now provided humanity with direct measurements from beyond the Sun's protective boundary. And the story didn't end there. In 2026, Voyager 1 is still traveling outward. It is now more than 25 billion kilometers from Earth and continues moving away from the Sun at roughly 17 kilometers per second. At this distance, radio communication becomes painfully slow.